Hi everyone. In this video, I want to cover leave P out cross-validation. Now, cross-validation is a specific technique that we use in machine learning in order to be able to evaluate how a predictive model performs on a given set of data. More specifically, this is a technique that we use in order to minimize the effects of bias that are introduced in the way that we split up our available data into both training and test sets. Now, the format of this video is going to be as follows. First, I will illustrate to you what leave P out cross-validation is, and I will also work through a simple visual example. And afterwards, we will jump into a Jupyter notebook where I will outline to you how you can implement this type of cross-validation using scikit-learn. So without any further delay, let's jump into the content of this video. So leave P out cross-validation is one specific approach that we can use in order to evaluate how a predictive model performs. Now, more specifically, this is a type of exhaustive cross-validation approach, meaning that we are going to use every single possible combination of the data when evaluating our model. The upside to this is that this approach is more robust against the introduction of bias. The downside of this approach is that it is computationally expensive. So here we can see on the screen just a simple illustration of what exactly is going on during cross-validation at a very high level. So the top bar here, the blue bar, represents the total amount of data that we have. And within cross-validation, we are essentially taking this total amount of data and we are splitting it. We reserve a portion of it for training our model, and that's what's shown in green here. And then the orange portion of the data is going to be used to test or evaluate our model. Now, this illustration just shows one single split, but in practice with cross-validation, we repeat this many, many times. So we basically alter what data goes into the training set and which data goes into the test set. And we repeat this over and over again to evaluate how well our model performs. Now, we can work through a very simple example of what goes on with leave P out cross-validation. So here what I've shown is a very simple toy data set. It is represented by these four shapes. You can think of these four shapes as being individual samples in our data set. So this data set only involves four specific samples. Now, how would our arrangement look like if we want to perform leave P out cross-validation? Well, we first have to know a little bit about how leave P out cross-validation works. So what we're going to do is from our total amount of data, we are going to extract out P number of samples. So P is just an integer. And we are going to repeat this as many times as is necessary to get every single possible combination of P. So for the purpose of this example, we are going to choose P to be equal to 2. So we want to set up each train test split such that we get every single possible combination where the test set is of size 2. Mathematically, the number of splits that we're going to do is n choose P. And so in our case, this is going to be 4 choose 2, which means that we can expect to have 6 unique splits in our data. So let's go about and actually start to visualize what this is going to look like. So the first train test split, we can just copy it directly above. So then our training set is just going to be the pentagon and the circle. And then our test set is going to involve the triangle and the diamond. So that's the first arrangement that we've got. Now let's try to change it up a little bit. And for the second arrangement, let's move the pentagon and the triangle to be part of our training set. And then we're going to set the circle and the diamond to be our test set. Okay, so this is another different combination. Now we can take this yet further. So now let's choose, say, let's move these over here. And then what I'm going to do is copy this over and move this into our test set. So now we have a different combination. In our test set, we now have the circle and the triangle. So now we've got 3. Let's keep the diamond as part of our training set for the next combination that we're going to use. And let's see what other combination we can have. So I'm going to keep the circle up above, and now the triangle and the pentagon are going to be in as part of our test set. So now we've got 4. We can keep the pentagon to be part of our test set. Let's see what other combination we can use. We've already got the triangle. We can move the circle down. So this forms another unique test set, and then the other 2 data points then go up above. Okay, so now this is the 5th arrangement that we've got. So we just have one more left to exploit. So I think I'm going to keep the pentagon down. Then we get the diamond. No, sorry. Take the triangle and the circle. Okay, so here, if we zoom out a little bit, we see the 6 different possible combinations of this data. So this is just a very simple illustration of how leave P-out cross-validation is constructed. One thing to take away from this is that you can see that the number of iterations in this cross-validation is going to explode. We have a very simple data set here of only 4 samples, and yet even with just having a test set of only 2 samples, we get already 6 iterations. This is one thing to keep in mind with exhaustive approaches to cross-validation, is that the number of iterations you can go through can be really enormous. And so in practice, normally, exhaustive approaches aren't actually used. They prove to be computationally they're too expensive. But in any case, it's just good to know that these approaches are possible and that they are available to you. So with all of this being said, now that we have a general framework for how leave P-out cross-validation works, let's jump into a Jupyter Notebook and I can show you how we can actually implement this approach using scikit-learn. So now we're in a Jupyter Notebook, and we will quickly work through how we can implement leave P-out cross-validation using scikit-learn. So the first cell that I have here is just going to be used to import all the packages that we're going to make use of here. So let's just run this cell. And now I'm going to make a simple toy data set using the make classification function from scikit-learn. So this toy data set is going to involve 50 samples with 10 features, 5 of which are going to be informative, 2 of them are going to be redundant. And this data set is going to comprise of just 2 classes, and there's going to be a slight class imbalance between them of 40 to 60%. So let's just create these data. And the model that I'm going to be using as part of this analysis is just a simple decision tree classifier. I'm going to specify that the maximum depth for this classifier is going to be 10. So let's create this model. Okay, and now we can start with our leave P out cross-validation. So specifically, what I'm going to do here is I'm going to set P to be equal to 4. So for every single train test split, in this case, 4 samples are going to be left out, and we're going to test our model on those 4 samples. The remaining 46 samples will be used to train the model for that iteration. So the way that we set this up is we call this function called leave P out. If we go back up towards the top, we can see that we imported that from scikit-learn model selection. So this is where we bring it in. And what this function is going to do is it's going to return an object where we can extract out the indices of our data for every single split. So let's set up this object, and we can also count the number of splits that we are going to do as part of this analysis. So let's run this cell. Okay, and we can see that we're going to do over 200,000 splits. So keep in mind, this is a very small data set. It's only 50 samples, and the test set itself is relatively tiny. It's only 4, and yet we have this enormous number of splits. This just emphasizes the point that I illustrated earlier, that these exhaustive approaches can get computationally very expensive. Okay, so we have this all set up, and now we can run through this loop. And this loop is basically going to cycle through every single set of splits that we have computed up above. And then I'm just going to extract out the training and test data, and then fit our model on the training set, and then generate predictions and store those predictions of the model along with the true labels. So that's all I'm going to do in this loop. I'm also timing it, so let's see how long it takes to do this. Okay, this is finished, and it took about 1 minute to run. So that's not so bad, but for a data set this small, it is actually quite a bit of time to run. Now, just for the sake of interest, let's evaluate our model. Let's see how well it does. And we can see that these results aren't necessarily that great. However, we are using a very simple classifier, and that can explain why these results are not necessarily the best. But in any case, this illustrates how we can go about doing leave P out cross-validation in Python using scikit-learn. So this concludes the video. If you're interested to take a closer look into the Python code that I presented here, the notebook that I used is available on my GitHub. You can find a link to this notebook in the description below. Now, if you liked this content and learned something from it, please like, share, and consider subscribing to the channel. Your support is greatly appreciated. Have a great day, and I'll see you in the next video.